Hello everyone, welcome to the JCE Connect. In this particular session, we'll be learning module on gear trains. So before proceeding on the gear trains, let us define gear. A gear is a toothed wheel which is being used to transmit motion and power from driver shaft to the driven shaft when both the gears are having successive engagement. So gear drive is a positive drive because the gear drives are being used wherein the center distance between the both shafts is very small. So let us move towards the gear train. So a gear train is a combination of two or more gears which is used to transmit motion and power from one shaft to the another. As it is visible from the sketch, there are two gears and both the gears are meshing externally, where motion and power from the driver gear is being transmitted to the driven gear. So a larger gear is being called as a gear and a smaller gear is being called as a pinion. So the nature of train depends, or that is being used, depends on the velocity ratio that is being required and the relative motion and the position of the axis of the shafts. So a gear train may use either spur gear or either spiral gear or either bevel gear, wherein gear train is necessary because it is used to obtain large speed reduction ratios, and this, in doing so, increases the torque. The gear train finds applications in automobiles, clocks, watches, machining tools such as lathe machine, milling machine, drilling machine, etc., and in turbine generator sets. Electric motors are used with the gear system to reduce the speed and increase the torque. So let us see the types of gear trains. There are four types of gear trains. The first one is a simple gear train, second one is compound gear train, third is reverted gear train, and fourth one is epicyclic gear train. So let us study in detail the simple gear train. A simple gear train is a gear train wherein only one gear is being mounted on each shaft. So this is clearly visible from the figure 1 there, and figure 1 is being depicted with three figures, A, B and C. So figure A shows two gears, that is driver gear and the driven gear. Both the gears are being meshing externally, and since they are meshing externally, the direction of rotation of the driver and the direction of rotation of the driven is opposite to each other. Figure B, we are having three gears, driver, there is an intermediate gear and the driven gear. So the motion from the driver is being transmitted to the driven, and in between we are having an idler gear. We can see that the direction of rotation of the driver and the direction of the rotation of the driven is in the same direction, or they are rotating in the same direction. And in figure C, we are having four gears, that is driver, driven gear, and two intermediate gears or the idler gears. But in figure C, we can see that the driver gear and the driven gear are rotating in opposite direction. So from this figures, we can conclude that if we are having an idler gear which is odd in number, then the driver gear and the driven gear always move in the same direction of the rotation. Whereas if you are having idler gears or intermediate gears which are even in number, then the driver gear and the driven gear rotates in opposite direction. So let us look into the velocity ratio of simple gear train. So for the analysis purpose, we'll use figure B, and with respect to figure B, we can find the velocity ratio. So let us define some terms here. The number of teeths on driver gear or gear 1 is T1. So on gear 2 it is T2, and on gear 3 or driven it is T3. The speed of the driver is N1, the speed of the idler or intermediate gear is N2, and the speed of the driven or the follower is N3. So let us define the velocity ratio. So velocity ratio is defined as the speed of the driver gear to the speed of the driven gear. So that is N1 divided by N3. So with respect to this, first we are required to write the velocity ratio for gear 1 and 2, and then velocity ratio for gear 2 and gear 3. So velocity ratio for gear 1 and gear 2 will be speed of driver gear to speed of driven gear, that is N1 by N2, and the ratio of N1 by N2 is equal to T2 by T1. So similarly, we are having gears 2 and 3, and the velocity ratio is N2 by N3 is equals to T3 by T2. So if you want the total velocity ratio of that particular simple gear train as shown in figure B in the previous slide, so we are having there equation 1 and equation 2, and both the equation on both the hand sides, that is RHS and LHS, we are required to multiply it. So upon multiplying, we can see there N1 by N2 multiplied by N2 by N3 equal to T2 by T1 multiplied by T3 by T2. So since N2 being same, N2 gets cancelled, and since T2 being same, T2 gets cancelled. So therefore, the velocity ratio will be N1 by N3 is equals to T3 by T1. So in general, we can define the velocity ratio as the ratio of speed of the driver to the ratio of speed of the driven, or it can be also further defined as number of teeth on driven to the number of teeth on driver. So the next term associated with the simple gear train is a train value, and train value is defined as the reciprocal of the speed ratio, which is nothing but ratio of speed of the driven or follower gear to the ratio of speed of the driver gear, and that is N2 by N1 is equals to T1 by T2. We'll move on to the next gear train. So that is compound gear train. So in compound gear train, the gear train is being defined as if you are having more than one gear mounted on the same shaft, then the type of gear train is being called as compound gear train. So we can see it from figure there. So we are having 4 shafts. Driver gear is being mounted on shaft 1. Gear 2 and 3 is being mounted on shaft 2. Gear 4 and 5 is being mounted on shaft 3. And gear 6 is being mounted on shaft 4. So the gear 1 is being meshing gear 2. Gear 2 and 3 is being mounted on the same shaft. Gear 3 is meshing gear 4. Gear 4 and gear 5 is being mounted on the same shaft. Gear 5 is meshing gear 6. So we are required to find out the velocity ratio with respect to driver gear and the driven gear, that is N1 by N6. So with respect to this, we can see that since 2 and 3 are being mounted on the same shaft, the speed remains same. N2 is equal to N3, and 4 and 5 are being mounted on the same shaft, then the speed of gear 4 and gear 5 remains same, that is N4 is equals to N5. So if we write it mathematically or with respect to the velocity equations, so gear 1 is meshing gear 2, then the velocity ratio is N1 by N2 is equals to T2 by T1. Gear 3 and 4 are meshing, therefore the velocity ratio is N3 by N4 is equals to T4 by T3. And gear 5 and 6 are meshing, therefore the velocity ratio is N5 by N6 is equals to T6 by T5. Therefore the overall velocity ratio of the compound gear train is we are required to multiply equation 1, equation 2 and equation 3, and upon multiplying we get N1 by N2 multiplied by N3 by N4 multiplied by N5 by N6 equal to T2 by T1 multiplied by T4 by T3 multiplied by T6 by T5. Now since N2 and N3 is same and N4 is equal to N5, N2 and N3 gets cancelled and N4 and N5 gets cancelled. So we'll be left with N1 by N6. So N1 by N6 is equals to product of number of teeth on the driven gears to the product of number of teeth on the driver gears. So in general, if you want to define the speed ratio with respect to compound gear trains for number of teeth, so it is the ratio of product of number of teeth on driven gears and ratio of product of the number of teeth on the driver gears. So the train value will be reciprocal of the speed ratio. So with respect to simple gear train and compound gear train, the compound gear train is more advantageous with respect to the simple gear train, because the compound gear train is having an advantage over simple gear train, that is higher speed reduction from the first shaft to the last shaft can be obtained by using small gears. Hence compound gear train requires less space as compared to the simple gear train for the given speed ratio. Let us move on to the next type of gear train. The next type of gear train is reverted gear train. So in reverted gear train, if the axis of the first gear or driver and the last gear that is driven or follower gear are coaxial or coincident, then the type of gear train is called as a reverted gear train. So these type of gear trains are used in automotive transmissions, lathe back gears, watches, where minute and hour hands are attached to the gears on the same axis. So let us analyze this. So is it clear from the figure there that gear 1 is being mounted on a particular shaft, and gear 1 is meshing gear 2. Gear 2 and 3 is being mounted on the same shaft. So both are having the same speed there, and that same shaft is common shaft. And gear 2 and gear 4 is gear 3 and gear 4 is meshing, whereas the shaft 1 and shaft third, that is where gear number 4 is being mounted, are coaxial, but both shafts are two different shafts. So we can see that the direction of the rotation of shaft 1 and direction of the rotation of shaft 4 is in the same direction, and both the axes are coincident or coaxial. So it is clear from the sketch there that the center distance of gear 1 and gear 2 is distance between the two centers of gears, which can be written as R1 plus R2, and similarly for gear 3 and gear 4 it can be written as R3 plus R4. Since the center distance of gear 1 and gear 2 and center distance of gear 3 and 4 is same, so we can write R1 plus R2 is equal to R3 plus R4. So for most of the gears, though gears which have been meshing, the module is assumed to be same, and the circular pitch is also assumed to be same. Therefore, the number of teeth on each gear is directly proportional to the circumference or radius. So the circular pitch that is being defined as PC, that is 2 pi r by t, and with that we can also define the module. Module is defined as ratio of the pitch circle diameter to the number of teeth. So PC can be written as pi into m. So whatever that radius is there, radius can be written in terms of the module and number of teeth. R is equals to mt divided by 2. So that is in general can be written for each gears, gear 1, gear 2, gear 3 and gear 4. And once it is being written, we can substitute that in equation 1, and since the module being the same on each side, the module gets cancelled there. So we'll be left with T1 plus T2 is equal to T3 plus T4. So let us find the speed ratio. So if you are required to find the speed ratio, that is N1 by N4. First gear 1 and gear 2 is meshing, and next gear 3 and gear 4 is meshing. So N1 by N2 multiply by N3 by N4 is equal to T2 by T1 multiply by T4 by T3. Now since gear 2 and gear 3 is being mounted on the same shaft, the speed will be same. So N2 and N3 gets cancelled. So we'll be left with only N1 by N4. Therefore N1 by N4 is equals to product of T2 and T4, that is teeth, and product of T1 and T3. So in general it can be also defined as speed ratio is product of the number of teeth on the driven gears to the product of number of teeth on the driver gears. Let us move to the next type of gear train. The next type of gear train is the epicyclic gear train. Now in the epicyclic gear train, if we see the sketch, if the arm, that is arm C, if the arm C is being fixed, then the gear train is simple gear train. That is gear A and gear B are going to mesh, and this type of gear train is the simple gear train. But if in case the gear A is being fixed, then gear B is required to rotate with respect to the axis O1, or it is required to rotate upon or around gear 1. Such kind of motion is being called as epicyclic, and the kind of gear trains arranged in such manner are members which move upon or around another member, and such kind of gear trains are called as epicyclic gear trains. Now, the epicyclic gear trains, the velocity can be determined by using either tabular method, or it can be also being used with the help of angular method. The main advantage of the epicyclic gear train is that it can be used for transmitting high velocity ratio with gears of moderate size in a lesser space, and it finds application in back gear of the lathe, differential gear of the vehicles, hoist, pulley, block, wrist, and watches. So this is an introduction with various types of gear trains and the velocity ratios. So in the next module, we'll be dealing with the problems. Thank you.